John, here's the last problem that we didn't get to go over in class. So they want you to determine the actual yield in grams of the carbon tetrachloride if you have 175 grams of chlorine to start, and you're going to react that with methane gas. So they give you the percent yield, and the reaction is 75.4%. So again, I started with what I was given, 175 grams of chlorine. I'm going to multiply that by the molar mass. 1 mole of chlorine is 35.453. I carried the decimal all the way out, whatever they gave me on the periodic table. So I did that, grams, that's how many grams you have in a mole. And then I have to get to moles of the carbon tetrachloride. That's where I use the balanced equation. So 1 mole of carbon tetrachloride is equivalent to, or requires, I should say, 4 moles of chlorine. And you can see that right there, there's a 4, and right there, there's a 1 that they're too lazy to write. And then from there, we're in, so let me cancel some units. Grams of chlorine are gone, and then moles of chlorine are gone. Now I'm in moles of carbon tetrachloride, but I want to get to grams, so once again, I have to use the molar mass, and you can see down below, I showed my calculation for that. Again, I carried out the decimal just because I wasn't sure what your teacher wanted, but I got 153.823 grams of carbon tetrachloride per mole. And then when I do my calculation, I get 189.822 grams. And that's grams of carbon tetrachloride. Let me add that. And then I can calculate my percent yield from there using the formula we've been using. Percent yield is equal to your actual times 100 divided by the theoretical, which is always what you calculate. And so I multiplied 75.4 by 189.822, and then I divided by 100, and I got 143.126 grams. So I hope this helps. I'll see you tomorrow. Have a good night.